Hi guys, welcome. In this video, you will see the semi-routing traffic engineering demonstration with the use case semi-routing policy automated steering. My name is Hinwato. I'm a Cisco Technical Solution Architect, and this video is part of Cisco semi-routing and NSO demonstration. Currently, we rely on RSVP-TE to do the traffic engineering. However, the RSVP-TE has some limitation. There is no different SLA path per VPN because the RSVP-TE will forward the traffic all VPN to the same path. And then within the same VRF or VPN, we cannot differentiate the SLA path based on the services. So we will address point number 4 and number 5 with the semi-routing traffic engineering. Let's see the problem first. Here we have the L3 VPN service. We have two VRF or never slice, the autocar and 5G. We will use RSVP-TE to steer certain application here. Let's say we are gonna direct the Google service via router 5, 2, 4, and 8. Let's try to do it first. Let's go to the router now. Before, let's check the normal path. I'm gonna do the trace route. VRF autocar is 100. I'm gonna trace to the router 8, and the Google on the router 8 is 8121. 8121. Let's see the path. Focus on the last number here, 1, 3, and 8. 5, 1, 3, and 8. It flows through the upper path. Okay, now let's see on the other service, which is 8111 is BMW 8111. Okay, it's also use the same path. Let's see on the 5G services. It's a VRF 500 8511 with the same path goes to 8511 5G control. Okay, and then let's see on the 5G user 8521 also uses the same path 1, 3, and 8 because 1, 3, and 8 path is the best path based on IGP algorithm. It will use the best cost. As you can see here, we have the bundle interface. The higher bandwidth is available here. Okay, however, this will have weaknesses because other link will be underutilized, and in fact, maybe between link 3 and 4, which is smaller, will be get congested. So traffic engineering will help the situation, but however, can we direct only certain application to use other path? Let's try to do so. I will configure the RSVP-TE using Cisco NSO here. This is the web user interface of Cisco NSO. I'm going to access the service manager. Now the scenario is I want to direct from router 5 to router 8 only for Google application, Google service here. Let's go to the autocar. Here we have the menu, the RSVP-TE steering policy. I'm going to use it through, and then it will show another menu here. I'm going to type, okay, I'm going to direct Google from 5 to 8. Let's fill in the parameter. Google here from router 5 to router 8. Here 8. And then define hop by hop. First, it will be go to 2, 4, and 8. Okay. First hop is 2. And then second hop is 4. And then last hop is 8. Okay, let's push the configuration. It will push the interface TE tunnel based on the RSVP-TE on towards the router 5. Here. Let's check on the router. Let's check first on the Google service, which is 8121. I'm accessing router 5 here. Okay, 8121. The VRF 100 is AutoCAD. Okay, I think we make it. It flows via 2, 4, and 8. This is our objective initially. And can we check on others? Let's see on 8111, which is the BMW here. What happened is they also follow the same path, 2, 4, and 8. And then we check on the 5G. Same thing happened here, as well as the 5G control here. So it actually makes all the VRF on router PE5 to use the same path, 2, 4, and 8. This is not the objective, and that's why the RSVP-TE policy here will not help our objective. This is the concern of the address point 4 and 5 here. SAME routing has the automated steering capability. In this case, we can steer for the certain application to the certain path, even though they are within the same VRF. Sounds cool, right? Let's try it. First, let me remove all the RSVP-TE traffic engineering before. Here, let me delete it. And then I'm gonna remove the menu. That's it. Then, let's say we have the scenario like this. I'm gonna direct BMW, okay, follow the normal IGP base path from 5138, you know it. Now for the Google, I'm gonna steer it to 5, 1, 3, 4, and 8. And for the 5G application or service, for the control, 5, 1, 2, 4, 8. And then for the 5G, for the 5G user, and it will be 5, 2, 4, and 8. I'm gonna configure it to the NSO with SAME routing automated steering policy. Let's see on the Google first. This is the AutoCAD network slice. I'm gonna activate the SAME routing traffic engineering policy. Here we're gonna add the policy Google 528 with the SAME routing policy, SR policy. Okay, so I'm gonna select the Google service application, start from router 5 and to the router 8, and then let's define the hop. This is the first hop. First hop is router 1. I'm gonna fill in the prefix of router 1, 20 here, 30 here, the index, and then the last index is 40. Let's fill it by one by one. The next is the prefix of router 3. Then the next is the prefix of router 4. And the destination is router 8. 1, 3, 4, 8. Looks good. So next, we define the SR policy on the 5G. I'm gonna activate the SR policy and create two policy here, the 5G control, from router 5 to router 8, and add another policy 5G user from router 5 to router 8, and then let's define the policy here. This is 5G control from router 5 to router 8, and let's determine the hop 1, 2, 4. Okay, so there are 4 hops here. Okay, first hop is router 1 traffic seed. Second hop is router 2. Third hop is router 4, and the destination router 8. 1, 2, 4, 8, and then I'm gonna, let's fill in on the next policy. This is the 5G user from router 5 to router 8, and define the hop here. Specifically here, I'm gonna use the adjacency seed. It's already figured it out, 24099. Then, so next the second hop is traffic seed of router 4, and the last hop, which is the destination of router 8. Okay, review for a while, and then let's see on the native config CLI here. NSO is creating the semi-routing traffic engineering policy. It will use the automated steering for certain application towards certain path. Looks good. Then commit. After this, we are going to verify it again with the traceroute command on the router. What happened here? Semi-routing use the color features to differentiate certain application or certain service, and then steer it to the certain path. This has the advantage that the semi-routing traffic engineering policy can be used up to the PE level. Okay, let's see on the router here. Show run segment. Show segment routing traffic engineering policy tabular. Okay, we see that we have 3 new semi-routing policy, and the status all are ups. Let's try the traceroute. Let's try for the first, BMW 8111. Expected path is 1, 3, and 8. This is the best, IGP path, normal. Okay, same here, check. Next is Google 8121. It should go to 1, 3, 4, and 8. 1, 3, 4, and 8. Focus on the last number of the IP address. Okay, check. And then let's see on the 5G, which is a FreeRF 500, which is the 5G control 8511. Expected path is 1, 2, 4, and 8. 1, 2, 4, and 8. Check. And the last is 1521, which is the 5G user, should go to 2, 4, and 8. 2, 4, and 8. See here, semi-routing traffic engineering automated steering has the capability to differentiate its services for certain path. This will allow we have the optimization for all links and to provide the guaranteed SLA for certain application. RSVP-TE has complexity and limitation to achieve the same capability here. This is the beauty of the SAME routing traffic engineering policy. Let's see of the advantage here. So far, we have built the SAME routing network and applied the SAME routing traffic engineering policy, which allow us to have the benefit of simplified SLA path and then automated traffic engineering and steering. For further information, feel free to access to the samerouting.net/tutorials on the section SAME routing traffic engineering, and also a recommended SAME routing books here. You can access it from the Amazon. SAME routing part 1 or the foundation, and SAME routing part 2 is the traffic engineering. That's it, guys.